Today's topic is basic properties of electric charges. First of all, this is the additive property of charges. All the charges which are present in the space, if you want to add them, then you have to take the algebraic sum. Now, what is algebraic sum? Say you have these charges q1, q2 up to qn, then you have to take the addition of all these charges. Okay, but you have to take into consideration the sign of the charges. Positive charges are taken as positive, negative are taken as negative, and resultant charge is found here. There is one example. Say there are +1, +2, -3, +4 and -5 charge. Then just you add by taking into consideration their signs. Okay, then finally you will get -1 charge, resultant charge. Okay. Now the charge is conserved irrespective of any process which is taking place in the isolated system. Then the total charge of the system remains constant, or we can say charge is not created, not destroyed. So within an isolated system consisting of many charged bodies, due to interactions among the bodies, charges may get redistributed, but it is found that the total charge of the isolated system is always constant or conserved. So conservation of charge has been established experimentally also. Okay. So it is not possible to create or destroy the net charge carried by any isolated system. So in an isolated system, the total charge remains conserved. Okay. Now there is quantization charge, quantization of the charge. This is another property very important, you must have studied in your 10th standard. Okay. The total charge is always the integral multiple of the fundamental charge. Say fundamental charge is denoted by E. Okay. E is the fundamental charge, that is charge of electron or proton. Okay. So it is denoted by E. If there are 10 charges, then total charge will be 10 times E. If the electrons are there, then this charge will be negative charge. Okay, and if there are 10 protons, then this will be the positive charge. So total charge is always the integral multiple of the fundamental charge. In the international system of units, the unit of charge is coulomb, and it is denoted by the capital C. Okay, unit is denoted by capital C. Okay, a coulomb is defined in terms of the unit of electric current. Okay, now in terms of this definition, 1 coulomb is the charge flowing through a wire in 1 second if 1 ampere current flows through it. It means that if 1 ampere current flows through a wire, then we can say 1 coulomb charge will pass in 1 second. So after every second, we can say 1 coulomb charge is passing through the cross section of the conductor. Okay, now as you know that charge of electron is 1.6 into 10 to the power minus 19 coulomb. Just I am taking the magnitude, so positive I have taken. So if you have this much of charge, then you have 1 electron, we can say. This much charge is carried by 1 electron. Then if there is 1 coulomb charge, then how many electrons are there? If you simplify, then you will get 6.25, that is 6.25 into 10 to the power 18 electrons. So these many electrons, if they are combined together, then they will produce -1 coulomb charge. Okay, minus sign stands for electrons. If there is a positive charge, then we write +1 coulomb. Okay, now there is a Coulomb's law. This is very important, and now your chapter actually begins from this particular topic. Okay, Coulomb measured the force between 2-point charges and found that it varied inversely as the square of the distance between the two charges, and it was directly proportional to the product of the magnitude of the two charges and acted along the line joining the two charges. So it is very easy to understand. Say you have two charges, okay, which are having their values q1 and q2. Okay, the distance between these two charges is r. Then the force, either this will be a repulsive force or it will be an attractive force. If they are unlike charges, then there will be a repulsive force. If these are the like charges, then this force will be a like charges mean repulsive force, unlike charges an attractive force. Okay, unlike charges will attract and like charges will repel. So force will be directly proportional to the product of the charges, that is q1 q2 upon r square, that is inversely proportional to the square of the distance between them, as we have studied this in our gravitational force between two objects, that is F is equal to m1 m2 upon r square, where one constant was kept. Okay, that constant was universal constant of gravity. So F is equal to g m1 m2 upon r square, that we have studied. Likewise, this is the same rule regarding the charges, is inverse square law. Okay, so if there is a vacuum here, there is no medium, okay, between these two charges, and if they are kept at a distance r, then the force between these two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And the magnitude of this force is given by F is equal to k q1 q2 upon r square, where k is a constant of proportionality. Okay, the SI unit of k can be found, its value can also be found if you make k as a subject of formula. Okay, k is a subject of formula, then it becomes fr square upon q1 q2. It becomes fr square upon q1 q2. F is force, so its unit is Newton. R is distance, so its unit is meter, and square of it, so it becomes Newton meter square. Unit of charge is coulomb, so per coulomb square, and its value is found to be 9 into 10 raised to 9. So the value of k finally can be termed as 9 into 10 raised to 9 Newton meter square per coulomb square. Okay, here this constant k, which is seen in this equation, is having its value, which is given by k is equal to 1 upon 4 pi epsilon naught or epsilon 0, where epsilon naught is nothing but the permittivity of free space. It has its own value. Okay, so if you replace this k by 1 upon 4 pi epsilon 0, then magnitude of the force can be F is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. Here epsilon 0 is called the permittivity of free space, and its value is also found. Okay, its value is 8.854 into 10 to the power minus 12. Okay, SI unit. Now you can see the unit which is there, that of this epsilon, is the inverse unit of this unit of k, because both are inverse of each other, k and epsilon 0. Okay, so it becomes coulomb square per Newton meter square. Okay, now there is a vector form of Coulomb's law. Now try to understand this part. First of all, you have these two charges which are separated by some distance. Okay, this charge is q1 and the other charge is q2. Now if you take these two charges in a space, then this can be your reference point, and with respect to the reference point, the position vector of the charge q1 is r1, and with respect to the reference point O, the position vector of this charge Q2 is R2. Now try to understand. We want to find the force acting on 2 by 1. Force on second charge by first charge. Force on 2 by 1. Okay. Now if these two charges are positive, okay, then naturally the force on 2 by 1 will be in this direction. This will be the direction, because this Q2 will experience the repulsive force because of this Q1, and it will be in this particular direction which I have shown in this figure. So this will be the direction of force on 2 by 1. Now you want to show this direction in the Coulomb's law. Now try to understand, if you take unit vector of this particular vector, okay, if you take the unit vector of this vector, okay, this vector I have shown it by green line, okay, unit vector of this green line vector if you take, okay, then if you multiply force on 2 by 1 by that unit vector, then it will show the direction of the force. Now if you want to find unit vector, then vector upon its magnitude. Now try to understand this vector from 1 to 2. This vector from 1 to 2 I show as R21, beginning from 1 ending at point 2, that is vector R21. If you take the unit vector of this R21, then unit vector of R21 is vector upon the magnitude of this vector, that is R21. Now this is the basic thing that you should understand. Unit vector of vector R21 is vector upon its magnitude. This can be denoted by unit vector R21 cap. R21 cap. So if you multiply the magnitude of the force between these two charges by this particular unit vector, then it will give you the direction of the force. Okay, now this is explained here. Okay, see, these two charges are shown here. Okay, this is your first charge and this is your second charge. Okay, Q1 and Q2. Force on 2 by 1 is in this direction. First of all, try to understand this part only. Automatically this will be understood by you. Vector of 1 with respect to O is R1. Vector of position vector of 2 with respect to O is R2. And this which I have explained, that is vector R21 is vector R2 minus vector R1, that is according to the triangular law of vector subtraction. Okay, so this is the direction of vector R21. Vector R21 can be written as vector R2 minus vector R1, okay, according to the triangular law of vector subtraction. Okay, now if you find the unit vector of this, then vector R21 and the unit vector of it is R21, then it becomes R2 minus R1 upon magnitude of R21. Now magnitude of R21 means the distance between these two charges, that is Q1 and Q2, or length of this particular line. This particular line is having some length. This length is measured, and that is nothing but the magnitude of vector R21. Okay. Now this part is explained over here. Let us consider the position vector vector of charges r1 and r2 are, as you know, that they are denoted by vector r1 and vector r2. These are the position vectors. Okay, r21 is taken as r2 minus r1. Okay, and if you want to take r1 minus r2, if you want to find the force on this particular charge, then the repulsive force will be in this direction if both are positive charge. Then force on 1 by 2, that will be in this particular direction, which is in the opposite direction of f21. So you have to take, instead of vector r21, we should take the vector r12, and that will be r1 minus r2. Okay, so that is written here. Okay, the magnitude of the vectors r21 and r12. Now try to understand this length of blue colored line. This length of blue colored line is not going to change either you take r21 or r12 magnitude. That magnitude is going to remain constant whether you find the force on 2 or you find the force on 1. This distance is not going to change. Okay, so r12 and r21, they are same, or their magnitudes are found to be same. r12 is equal to r21. The direction of the vector is specified by the unit vector along the vector, and these unit vectors, as I have explained, it is unit vector r21, that is vector r21 upon magnitude of r21, or unit vector of r12, then vector r12 upon magnitude of r12. Here these unit vectors r21 and r12, they are equal in magnitude but opposite in direction. So negative sign is missing here in your textbook also, just you go through it. Unit vector of r21 is equal to minus, try to understand, minus unit vector r12. Okay, so if you write this Coulomb's law, that is force experienced by the second charge due to first charge, force on 2 by 1, then this magnitude is going to remain constant 1 upon 4 pi epsilon 0 q1 q2 upon distance between them and square of it, that is r21 square. But this here becomes unit vector r21. That vector is in the direction from 1 to 2. 1 to 2. Force on 2 by 1. That is like this. This is the direction of, that is say q1. Say this is q2. So unit vector r21 is from 1 to 2. Okay, so force is in this particular direction. Okay, so you can also write this in your notebook, r21, that is unit vector is nothing but vector r2 minus vector r1 upon magnitude of r21, that is length of that blue line which is shown in the figure. Okay, similarly you can write force on 1 by 2, but that force will be the opposite of this, the direction will be opposite. Okay, so f21 and f12 are equal in magnitude and opposite in direction. Okay, this equation is valid for positive and negative both the type of charges. Okay, if you want to write f12, that is force on 1 by 2, then there will be a slight change, only unit vector will change. So the force will be opposite. Force will be opposite to the force on 2 by 1. So we can say force on 2 by 1 is opposite of force on 1 by 2. Okay, so force on force on 2 by 1 is equal to minus force on 1 by 2. Okay, force on 2 by 1, this is the force on second charge by the first charge. Okay, which will be opposite to the force on 1 by 2. So force on 1 by 2 is equal to minus force on 2 by 1. Here in our textbook, just you go through it. F12, okay, F12, that is force on 2 by 1. Force on 2 by 1 is equal to negative of force on 1 by 2. So the Coulomb's law agrees with the Newton's third law, that is forces are in pair and they are always, one is action, then the other one will be the reactive force. Okay, thank you.